so much for having me on SegaNet as Mentor of the Month. You always hear that phrase about standing on the shoulders of giants, and after having heard Svet's talk and then Morgan's talk, I wasn't really sure what to throw together for this, and it will probably be a fairly short talk. I have some slides to go through that are will show some things about my research and what I do right now as a graduate student, but then I just wanted to talk more about telling stories and about how important that is to me in science communication and in outreach. Because I think that telling stories is really what makes mentoring happen. By sharing stories about science and engineering and mathematics and stories about philosophy and what we do, I think that's the best way to teach others, is to share our stories about our lives. So I'm going to click into, hopefully this will work, 2D mix. Okay, it looks like it's showing you this picture. For those of you who can see my face, yes, I did shave off the beard. It is no longer a luxurious manly mane like it was before. But I know now that I belong with a nice long beard, and even more so now that I've shaved my first long beard off, I've realized that that vision of myself becoming the old storytelling man with a long white beard flowing down to my knees is probably gonna happen. But yeah, so I called this talk So There I Was, because that's how I like to tell stories. I like to tell stories about where I was in my life at a certain point in time and what I've learned along the way in science and in the things that I've done so far. And so in the abstract for this talk, I put together this idea, that I would be talking about being on a glacier and doing research and feeling somewhat chilly, to being on a stage and talking in front of a large group of people and feeling kind of nervous. And that's what I intend to talk about here with you today. On the left in this image, you can see a picture of me standing on a glacier at Borg Pass in the Canadian high Arctic, where sulfur deposits form on the surface of the ice every summer, and I'll talk shortly about how cool that really is. And then on the right, some of you might know that I've competed last year and won a preliminary round of NASA's Famelab. Famelab is a science communication competition where scientists, mostly early career scientists, will compete against each other, giving short 3-minute speeches on some topic in the science that they do. And it's been a fantastic experience for me. I've competed twice now. The first time I was X'd out before I even got to the final round of the evening, and then last summer I made it through both rounds and managed to win, and will now go to the national event for Season 3 sometime early next spring. And Sanjoy saying that all of us on the chat did Famelab, which is fantastic. That's awesome. So I'm going to talk first about my research, and it's one of those things as an early career scientist, you always have to talk about what you're doing in research. But research isn't the only important thing to me, and maybe not even the most important thing to me, but I think it is pretty cool. Because last year I got to travel to one of the most remote places on the planet and go check out this site that you can see in this image, where yellow elemental sulfur is being deposited on the surface of a glacier in the Canadian high Arctic. Not many people in their lives will get to go have experiences like these, and so for me to tell a story about the science that I do, it's always best to start off with how cool it is just to travel around our world to learn about how biology and chemistry and geology on our planet function together to make life on our biosphere, and also to teach us about the possibilities for life elsewhere. A lot of times when I give this talk, or talk about my research, I like to call it something along the lines of "something's eating the yellow snow." If you remember that Frank Zappa song, "To watch out where the huskies go and don't you eat that yellow snow." Well, in my case, I'm actually interested in what's eating the yellow snow and what's making the yellow snow. What processes are involved in forming sulfur on this glacier and in stabilizing it and keeping it present over time. That image you can see there of the sulfur on the glacier, that sulfur stream goes 1.5 kilometers roughly down this valley. It's a very aerially extensive deposit of elemental sulfur on top of the ice that really shouldn't be stable for a very long time, but as long as we can see it present in the valley, it's there throughout the summer until the snow comes in the fall. And just a quick note, that is my dog. That's my husky, Darwin. But moving on, I love sulfur. And maybe it's because of my research that I've gotten so into it, but the more I read about sulfur, the more I find it to be the coolest chemical element that exists. Sulfur is the oldest single chemical element that we actually had an idea of what it was. It was brimstone in the book of Genesis. The Egyptians in the Eborus Papyrus talked about using it as medicine to put on disease of the eyes. I'm even reading a book right now by Solomon Kroonenberg, this fantastic Dutchman. It's actually been translated to English because he doesn't speak English, but it's called Why Hell Stinks of Sulfur. And basically, as a geologist, he goes and travels around the world throughout this story of this book to look at mythology of the underworld and try to compare that to what we now know of the geology of the world below our feet and the deep subsurface. And so sulfur is important. That fire and brimstone from volcanoes that people related to hellfire really is one of the most important chemical elements. Outside of carbon, it forms the most chemical allotropes, or different forms of atoms all kind of adhered together in various ways. So carbon can make these really long chains and cyclical molecules, and then these large things like buckyballs and those kind of things. Well, sulfur does the same kind of thing. It makes long chains and cyclical molecules, and there's lots and lots of them to study. And sulfur is really cool. So some of our knowledge of the ancient history of Earth is based on sulfur chemistry, on isotopic evidence from sulfur, as well as where we see sulfur and don't see sulfur in various parts of our planet can teach us about how life was on Earth, say for instance before life breathed oxygen. And I had to give a shameless plug for my blog. Hopefully you've seen it. If not, go check it out. It's giving me a chance to write for fun, which as an early career scientist doesn't always happen all that much. We have to focus on writing research articles and writing our dissertations. And so to get a chance to write something else is great. And this is a post I put up not too long ago talking about the smells that we have and that we experience in the world. A lot of them are based on sulfur, especially the smells of the odors that come from our rear ends. So, the smell of a fart comes from the sulfur molecules inside of us that comes from the bacteria living inside of our stomachs, which is pretty cool to think about. And Sanjoy's saying we should bring that blog from SegaNet. Yeah, we should do that for sure. So sulfur is important for our bodies, for our biology, as well as for biology on Earth in the past, and for our knowledge of astrobiology as well. And that's where my field site kind of comes into play. My field site at Borg Pass has many times now been called one of the best analogs on Earth for Europa, a small moon of Jupiter. On Europa there is an icy crust, maybe thin, maybe fairly thick, with a deep subsurface ocean below. And many of us hope that there's been communication in the past, chemically and physically, between this ocean and the surface to tell us about the processes going on in the deep subsurface. And at my glacial site, we have an area where there's a glacier, so this crust of ice, with fluid in the subsurface being connected to the surface by these springs that bring water rich in sulfide or reduced sulfur to the surface where it gets oxidized. And the picture you see here in this Popular Science article was an image taken back in 2000. We've been exploring this field site since 1988. Most of the work done since about 2000 and 2001 or so. But my collaborator, Stephen Grasby, who you see here in this image, has been there nearly every summer since the year 2000. And these springs that form this sulfur, they change location from year to year. They change in the speed at which the rate at which the fluid is coming out. And then last year, there wasn't actually a spring at all. Back in 2006, my friend Davnit, who's now in Madrid at the Center for Astrobiology, went to Borup, and she saw some more of this sulfur in unique ways. And I just recently saw this on Facebook. She posted an image that our field site will once again be called one of the coolest sci-fi landscapes you can visit on Earth in an upcoming issue of Mental Floss. So keep your eyes out for that. If not, follow my Facebook, and I'll surely post the article. But then getting down to the brass tacks here, my field site is in the Canadian High Arctic on Ellesmere Island. I have it outlined here in yellow where this island is located. It's pretty close to the North Pole. I found out that there are two small islands that are part of Greenland that are actually technically further north than the northernmost part of my island, but I don't really count them, so my island's pretty far up there. And this is that image I showed you before, looking down at the sulfur staining on the glacier from helicopter back in 2006. And again, this deposit you see here in this image is about 1.5 kilometers long. And I mean, it's just visibly yellow from the air and from the surface. When you're looking down, you can see this yellow staining. Last year, I had the chance to travel up to this field site, traveling for 2 days by 5 different airplanes and then a helicopter just to get there. And this is what I saw. Last year, there wasn't an active spring flowing. We couldn't find any source of the sulfur forming, but we did see this really cool structure we're calling the icing. Very thick structure, full of ice, covered in sulfur. You can kind of see that greenish yellowish color of sulfur in this image. And we think that the area that I have labeled here as a blister that sticks up might have been where a spring was flowing at this site earlier in the year last year, going up into the spring, and then by the time the summer came, the spring for some reason got cut off, and then this blister and this large icing remained. And the area of that icing is roughly 2 or 3 football fields in size, about 200 by 300 meters or so. And down at the bottom I have labeled Sulphur Falls. Those of you watching, I'm sure, or hopefully, have heard of Blood Falls on the Taylor Glacier in Antarctica, and there they have a really beautiful structure where, again, we have communication between subsurface fluids and the surface going through ice. In their case, though, the deposits that come out are a blood red color because of the iron being oxidized in their spring fluids. Well, at my field site, there isn't any iron in the spring fluids, at least it's extremely low amount of iron in the spring fluids, and so it doesn't oxidize, it doesn't change the color. Instead, we see this beautiful yellow from sulfur. But just to have a little fun with the guys who do the work on Blood Falls, we decided to call this area of the icing, where the ice has fallen over and then become deposited in the sulfur, we call that Sulphur Falls. And this is an image from last summer of my advisor looking at a melt pool that formed on top of that icing. So through the summertime heat, the sun that all day long would just circle around the sky and never set. And so there was plenty of heat from the sun to warm the surface of that icing over time. And one thing that was really cool was that bubbles of hydrogen sulfide started coming up through melt pools that were forming on the icing, and where the bubbles would come up, they would form elemental sulfur on the surface of these bubbles. You can kind of see them in the bottom of the image that I have here, but even better, you can see it here, where this is me collecting some of that sulfurous, goopy material to try to look at it. I said earlier when I showed you a picture of my husky that I'm interested in what's eating the yellow snow, also in what's making the yellow snow. I'm interested in how the sulfur is being deposited here. Is it solely a chemical process that doesn't require life, that sulfide and oxygen from the atmosphere are coming together and making this elemental sulfur? Or can it tell us something about the microorganisms that we know live at this site? There's a postdoc right now working in our lab who's looking at the biomineralization of sulfur by organisms that we've isolated from this field site. And it's very cool. They create these long carbonaceous structures that get encrusted in elemental sulfur, and I'm now interested to see if they're doing that in the field site as well. And so last summer I collected this bubble material and I took it back to my lab. This is an electron microscope image looking at some of that sulfur now really close up. And so it looks like little nanospheres or little globules kind of adhered together to make around micron size globules, and then they get bigger and bigger and they make these large cages almost. The image you see here, there's like this cage of globular sulfur with a hole in the middle. And Sanjoy's asking, where does the sulfur come from? Was Ellesmere formerly volcanic? No, there's no volcanism in this area currently. There was a very long time ago. We currently believe that the sulfur is coming from an anhydrite layer in the subsurface. So anhydrite is calcium sulfate. We believe that fluid, meltwater from the glaciers, is going down into the subsurface, liberating this sulfate, and then somewhere in the subsurface, sulfate's being reduced to sulfide, which comes up then in these spring fluids. And Julia asks if the goopy bubbles smelled like rotten eggs. Yeah, it really smelled like rotten eggs, but I don't really tend to think of it that way anymore. Since I've been working with sulfur for so long, I actually now really like the smell of hydrogen sulfide, and so for me it's not really a bad smell since I've gotten so used to it. But yeah, it definitely smelled that way all over the glacier. The highest sulfide we've ever measured is around 4.2 millimolar sulfide in these spring fluids, which is really high. And even this past summer, the highest I've measured so far is 3 millimolar, which is still really high. So like I said, it's forming these globules of elemental sulfur, and I'm interested to know if microorganisms are involved in that process. And something that I'm going to be talking about at AbSciCon, at an upcoming conference that hopefully you'll all be at, is how I'm now seeing various forms of sulfur in my samples. And one of these forms in particular that you can see in this image, I can't really explain just yet. I'm not sure what's happening to form sulfur in this way. So in this image you see in front of you, you can see that globular elemental sulfur stuff on the right-hand side, but then on the left-hand side is something that looks like a mineral, but is composed almost entirely of sulfur. And I'm not sure why sulfur is forming this smooth, faceted structure that appears to be associated with the globular stuff. It might be that one is forming from the other or vice versa, but I'm now in the process of trying to weed that out using physics and chemistry. And so I mentioned AbSciCon. I'm going to talk there. We only have 10 minutes, which is a bummer for a science talk, but I'll explain more about what I'm now seeing in this sulfur at AbSciCon. You can come see my talk on Tuesday, the 16th, at 3 o'clock in the afternoon when everybody's good and tired and I can speak as enthusiastically as possible and try to wake people up. And then I'm not going to give many stories there. I'll try to tell the story of the research, but I wanted to kind of show this story. This is a picture of me looking down now at that icing structure in the valley where the sulfur has formed on top of the glacier. I'm wearing a shirt there from a local coffee shop, or a local diner really, called Village Coffee Shop. I was there just before I left for my field site, and I saw this picture on the wall. It was a picture of someone wearing one of their t-shirts and standing by a sign at McMurdo Station in Antarctica. And I was like, oh, that's pretty cool, but my field site's even further away than that. McMurdo is at 77 degrees south, my field site's at 81 degrees north. And so I told the guy who owns this place about that, and I asked, if I go up there with one of your t-shirts and take a picture, will you put it beside his picture but make it just a little bit bigger? And the owner loved it, and he's going along with it. So now I'm going to have this picture on the wall at this diner just a little bit bigger since I'm a little bit further away. Even though I'd love to go to Antarctica, it was still really exciting to go to a place very few people have ever been to on our planet. And so I mentioned when I first started talking about telling stories and about how much how important that is to me. So Sanjoy said that everyone, at least on the chat here on SeganNet, has competed before, been involved with Famelab. So again, NASA Famelab is a short science communication competition where you give a 3-minute talk with no slides, maybe one prop, and you tell a story, and you use that story to get across mostly just one key idea. There's going to be an installment of Famelab at AbSciCon Monday, June 15th at 6 o'clock in the evening. There's also one coming up in a couple of weeks on Saturday, May 30th at 6 o'clock in the evening at the Phoenix Comic Con. I won't be there for that one, but should be really cool. For those of you who have competed but don't want to compete again, come join me at AbSciCon. I want to go watch my upcoming competition for the spring. But the way that I won in Famelab last summer was by telling a story about my field site. And so I'd like to share that story, but I have the video. I'm going to see if it will play. If it won't, then I'll just tell the story with words. But let's see if this will work. Maybe not. Can you guys hear that?
How far would you go for the work that you love? Would you put yourself into harm's way? I'm going to tell you about some work that I love, and I'm also going to tell you a story about how it nearly killed me. But I need your help to tell this story. So right now, could everybody please stomp your feet? A little louder? Great. When I'm telling my story, I'll throw my arms up in the air and start stomping your feet. When I stomp my foot, you can stop. Let's try it once. Fantastic. Thank you very much. The work that I love involves field science. I get to travel around the planet to study microorganisms in their environments, to study how they affect the environment, how they cycle various elements, sulfur primarily. This summer, I had the opportunity to fly up to the high Arctic, to a glacier on an island called Ellesmere. If this is North America on a map and Greenland's up here, my island is right up there at the very top, at 81 degrees north. At this glacier, microorganisms in the subsurface are cycling sulfur so much that when waters erupt out of the glacier in the summertime, they bear high levels of hydrogen sulfide. That's that rotten egg smell you might have smelled before, or that you might smell if you've gone to Yellowstone National Park. When the sulfur comes out on the surface, it makes big mats on the ice of yellow elemental sulfur, yellow snow, and also not the kind you can eat. This site's important for us because we treat it as an analog to Europa, a moon of Jupiter that's also covered with ice and has sulfur on the surface, and for possible past environments on Mars. So here's my story. This year, the 22nd of June, I'm standing on the glacier, yellow all around from these mats of elemental sulfur that I know there's microorganisms all around in as well. I can smell that rotten egg, hydrogen sulfide smell, and I'm in an area where a crevasse comes down from the side of the glacier into the toe by this covering of sulfur. It's the midday, about noon. We're working, I'm taking some samples and doing some science and chatting, and suddenly I hear this great roaring sound. And I turn around to an explosion of ice flying out of the glacier towards us. Where we were standing, there dropped at least 12 tons of ice, 10 feet above where we were at. We had just enough time to run as fast as we could away. And that's how my field site almost killed me. But you know what? It was completely worth it.
Awesome. Stop this. So yeah, that was the talk that I gave at NASA Famelab last summer, and yeah, 12 tons. That was a back of the envelope calculation though. I just tried to do a volume and then take the density of wet ice and figure out what the mass would be, and we figured about 12 tons. This is a picture of my collaborator John Spear. He's a researcher at the Colorado School of Mines. Right after this thing had fallen down and started to subside a little bit, he's here taking an image of it. So you can see the crevasse in this image where all of this ice and snow came blowing out of the glacier towards us. We were 6 scientists just running crazy trying to find some place to get to that was high enough that just in case this thing continued going, we could get away. We really had no idea what was happening at the time. I mentioned that my collaborator Steve Grasby's been there almost every summer since 2000. And he said that he'd never seen this happen on our glacier before. But in the background, in this image, you can see all that snow and ice piled up. Basically, if you would walk back to where that's at, we had been back there earlier at a small lake that was down under that. And yeah, so all of that snow and ice would have easily covered us. And we were far enough away that there's a good chance the rescue teams would have taken quite some time finding our bodies. So yeah, it's kind of scary to think about, but it's worth it. You know, you get a good story if you survive, but it's also one of those things that when you're doing research science in remote places, there are things that can go wrong, and so you always have to watch out for those kind of things. I'm going to switch over now back to just the camera and get rid of the screen. So hopefully that works there. Yeah, because I like talking without slides as well. I think it's the best way to tell stories, and so I wanted to make this talk kind of a little bit my research, and then also just talk for a moment about what really drives me in the sciences. I love my research. I love sulfur, in case you couldn't tell, and it's fantastic to have a chance to travel to a remote field site and do research science. But what really drives me a lot is sharing science with other people. And I prefer doing that through the medium of speaking. I like writing. My blog has given me a chance to write creatively, and I hope to write a lot more in the future, but I really enjoy speaking at the public level. I think that if we can learn how to take these really abstract and sometimes hard to digest scientific ideas in our research and break them down into really simple concepts for the public to understand, it will help to make our society more literate in the sciences, which is absolutely necessary in our modern day and age. And so I want to tell a little bit about what I do to improve my speaking. I'm not that great of a public speaker, at least in my opinion. I feel like a good public speaker, but I know I have it in me to be a great public speaker. I think everyone has it in them to become great public speakers. It just takes a lot of practice and a lot of work. So I'm going to tell you another story right now just for fun. And this is the story about how I almost never spoke in public ever again in my life after I was 8 years old. One time, when I was 8 years old, I had to give a speech in elementary school for my class. The assignment was that each of us would take a historical figure, learn a little bit about them, just basically where they grew up, those kind of things, some key points of what they've done in their past, and then we dress up as those people and give a talk to the class. And I was really excited. At that time in my life, I loved Benjamin Franklin, and I was so excited to be Benjamin Franklin and to talk about him. And so I spent the entire night before this class with my parents at home, building my Ben Franklin costume, taking a coat hanger and cutting it down and turning it into spectacles, and getting a tri-corner hat from the local costume shop. I took my mom's shoes, her heavy wooden clog shoes, and I even had her socks on that I pulled up really high over my dad's pants to make it look kind of like stockings hanging down. And my parents had even gotten me a small coat that looked fairly authentic. And so I was so pumped to be Benjamin Franklin. And the day of the class came, and I went and got dressed up. I had my costume on. I was Benjamin Franklin, ready to tell the history of how great of a person I was, a thinker and an inventor and a politician. And it was my turn to stand up and tell the class what I'd learned about Ben Franklin. I had my little 3x5 note cards with information on them. And so I stood up, I walked away from my desk and up to the front, and hello, I'm Benjamin Franklin, and started as most kids would, a little nervous, but not bad. Basically looking at the cards and reading off the cards and trying to avoid staring at other people because they were staring at me. But at a certain point, as I was flipping through my cards, I came back around to the very first card, but I wasn't even close to being done. And at that moment, it hit me. I had left some of my note cards on my desk. And as an 8-year-old boy, I was terrified. I didn't know what to do, or how to handle something going wrong in front of a large audience. And so, and I should note, my teacher was recording this. And so, on video camera and in front of the class, I looked up, the fear struck my eyes and they went wide and dark, and my face went flushed and then really, really red. And then I broke out in hysterical sobbing and bawling, and the teacher had to come over and hug me and take me out of the room and help me to calm down. And we actually ended up calling my parents to come get me because I wouldn't go back in front of the class. I was so scared and terrified. And what's funny about that story, I know it sounds awful, but what's funny about that story is I've now met several people in my life who have almost the exact same story. That they had to do something in front of an elementary school class, and they also had this moment occur. And so, yeah, so those things happen, but I was so scared after that of public speaking that I told myself as a young person I would never do it again. But then throughout my childhood, my adolescence, I'd always admired people like Carl Sagan, a great speaker and communicator of science, people who could stand up in front of groups and give lectures and talks about how great science is and philosophy and culture and all that we know about who we are and our place in this universe. And I realized by the time I got to college that if I wanted to be someone like that who can share science with the public, or at least share my interests with anyone, that I would need to learn how to speak better and how to speak in front of people. And so my transition into becoming a good speaker was putting myself on the line and just trying it. Whenever I would have anything pop up, like an open mic night at a restaurant, I would try to give a speech. And I also took some public speaking practicum courses in my undergraduate years that helped a lot. But the best help that I got in public speaking came from Toastmasters International. If you haven't heard of Toastmasters, I hope you'll check it out. It's an international group with thousands of clubs across the planet, especially here in America. Almost every large city has at least one club. Here in Boulder, Colorado, we have, I think, 5, maybe 6 clubs. And these are groups that get together and people just give speeches in a comforting and safe environment where they can mess up and it's okay, where we work together to share our interest in becoming better speakers and better leaders amongst our peers, while also knowing that we can get good criticism. It's interesting how many people in our society think that criticism always has to be negative or a bad thing. Any criticism is good criticism, in my opinion. It always depends on how you take it. And the criticisms I've gotten through Toastmasters have helped me out in astonishing ways. When I first started Toastmasters about 5 years ago, I was still at that point where I get red in the face and nervous when talking in front of large groups. And now I've competed in Toastmasters speaking competitions. I've won a few of them. And it's given me a chance to hone my skills as a speaker. You might notice that even right now I'm speaking fairly fast, and I always have. I can speak really, really quick. But I've also, because of Toastmasters, learned how to slow myself down when necessary, which is always important in science talks. When you're talking about science with the public, it's important to slow yourself down to get those key concepts across. I've always found that just sharing a few key ideas and making it exciting and being enthusiastic about it is much better than trying to just load lots of information at someone. And I think you probably all agree with that. So that's my story of where I've been and where I'm going right now with my speaking as well. I'll be competing in Famelab next spring. I'm very excited. I don't have any speeches together yet for those of you who might be competing with me, but I'll start working on some here soon. I've met some of those Toastmasters speakers who win these really large national and international speaking conventions, and I've heard some of them, even for a 5-minute talk, will sometimes rehearse that talk and edit and revise that talk hundreds of times before they finally get to something that's actually a winning piece. So for those of you who know me well, in the coming months I'll probably be practicing my talks for Famelab, and I'll be working on putting together other talks that I can give here in Boulder and in other venues where I can share science with my fellow scientists, but also with the public, which is very important to me. And I don't know where life is taking me right now after my PhD, but having done the mentoring program now through SaganNet and having a chance to work in mentoring and to work in science communication, I'm pretty sure that I'd like my career to go somewhere in that venue. I could be a professor and I could teach, but I really am interested in sharing science with the public. And so that's kind of where I plan to go. And so that's kind of me in a nutshell. That's my research right now and the thing that's really driving me in sharing science. So I guess I'll bring the talk to a close right now, but leave everything running. I have the main room chat up, so if anyone wants to ask any questions about sulfur and my research in the Arctic or about being a public speaker, feel free to ask right now, and I'll keep my eye out. Thanks, Sanjoy. No questions yet. Oh. How do you know it's anhydrite and not another form of calcium sulfate? Sanjoy asks. Good question. So not 100% certain. No one's done any boreholes in the valley to see the exact stratigraphy of the subsurface. But the only sulfur-rich horizon in the area regionally is something called the Otto Fjord anhydrite, and we're pretty sure that that goes under the site as well. Stratigraphically, it should be under the site, and there shouldn't be any other form of sulfate or sulfur present that we know of. And isotopically, the fluid coming out, the reduced sulfur and the more oxidized sulfate, sulfur, the isotopes on those two things match with the reduction of sulfate by microorganisms in the subsurface from this anhydrite bedding of the Otto Fjord anhydrite, having measured the isotopes of a local outcrop, I believe 20 kilometers to the north. And Julia says, besides the near-death experience, what was a major challenge in your field research? Good question. I found out last summer in my field work that you can't always trust airlines. And I know that's probably a crazy thought, right? Who would think that you can't trust airlines? But First Air is an airline of northern Canada. They run flights throughout the islands in Nunavut and Northwest Territories. And we had shipped a lot of our equipment up to a research base called Resolute on a small island south of my island, where we were planning to stage our trip. On one of our flights up, we were going to stop there for a night, get our equipment, and then fly into our field site the next day. When we arrived at this research base at Resolute, we discovered that a lot of the stuff that we had sent up 2 months earlier was missing. So it turns out that this airline, First Air, without notifying us, took all the chemicals that had MSDS sheets in the boxes with them. So any chemical that I had put in a form describing what it is and saying whether or not it's hazardous, even if it's not a hazardous chemical, they took all those chemicals out, put them into a box, and threw them on a shelf. And then 2 months later, when we showed up, those chemicals weren't there. And what was a bummer about that is that we spent a lot of money, and specifically NASA spent a lot of money getting us up there, and some of those reagents, some of those chemicals that we wanted to have with us were really important for the work that we wanted to get done, and since they weren't there, there's a lot of things we could have done that we just weren't able to finish up in the end. I'll give you one example. I took along a really awesome gas-powered coring drill with the intention of coring ice and coring rock in the valley and getting really good geological samples to work with. And unfortunately, the airline took the oil that was necessary to run that drill. And so one day I was out with my drill knowing that it was going to seize up at some point because these two-stroke engines, they can't run without being lubricated. And so I was drilling down into the permafrost with a coring bit, and the drill seized right at the worst moment when the bit was about 1.5 feet into the permafrost. When that happened and the drill seized and stopped, the bit immediately froze into place. So then I had this long metal bit stuck in permafrost, which is basically like a rock at that point because it's so cold and so hard. It took us about 5 hours with rock hammers pounding and digging at this permafrost just to get the drill bit out. At one point, we almost just wanted to say, forget it and just bury the thing and pretend it never happened. But any good scientists, when you're in any field site, you want to take care of your field site, nurture it, and not leave your trash everywhere. And so it was upon us to get this thing out. And so yeah, we spent 5 hours doing that. So, but yeah, it wasn't fun. It's one of those things about field research is that you can't always depend on other people, especially when it comes to things like airlines. They could have just told us that they'd taken these chemicals out and given us some guidelines for what to do to get those chemicals up there, and that never happened, unfortunately. So maybe in the future I'll take every chemical and label it as water and give it some little code that I then know what it really is. It's unfortunate to say that, but that's kind of the way the world works then, right? Yes, that is very frustrating. And I'll wait another minute or two for more questions if there are some. I'll click over to the second live here too and have a look at my face. Oh, it's not good. Click back. Are you going to regrow the beard? Sanjoy asks. Absolutely. So I have a little bit of growth going on right now. I shaved the beard down. For those of you who are my friends on Facebook, you might have seen the transition phase as I slowly removed the beard and went to the Klingon mustache and then just the goatee and the mohawk. And then I went down and removed everything. And now it's time to grow the beard back out. Like I said when I first started, I now know that I'm going to be one of those old men with a long white beard who sits around and just rants and tells stories all day. And I know at some point that's going to happen, and hopefully I'll have a chance then to look back and be like, yeah, it was totally worth it, all these experiences and stories that I've told along the way about those experiences. Yeah, fantastic. Thank you so much, everyone, for watching. Thanks, Sanjoy and Sarah, for putting this together. Thank you, SegaNet, for making me the mentor of the month this month. I really want to see our mentoring programs build up more and more. It's been so great so far being involved and having a chance to work with elementary school students in Arizona with their science fair projects, and I hope we can also develop it to the point where all of us have a chance to put in various ideas for how to do more and more mentoring with the public. So thank you very much.